Okay, let's talk about a very simple version of how to use a general linear model to try and figure out what is causing some effect in a really simple biological system. The pseudo data, this is all made up fake data. I'm going to fake it throughout this thing, so don't do this in the real world, obviously. Is I've taken a camera trap study where we've trapped for 24 hours, 6 days in a row. So I have 144 total data points. And then I have the thing that I'm attempting to predict is why are coyotes showing up in those pictures? Sometimes, but not other times. So I'm trying to understand what is driving the presence of coyotes, a binary yes no. The things that I have that I'm guessing as things that are predicting this are what is the temperature at the time, what is the rain, whether it's no rain, light rain, heavy rain, and whether or not it is what time it is during the day, right? Whether it's 0 all the way through 23 hours, so 24-hour total clock, right? What I'm going to put these into a general linear model and attempt to try and explain what's going on with coyotes. So let's take a look at what the data actually looks like. Right, so this is the way that I have set the data up. Again, it's all just randomized fake real data, or not fake real data, it's fake data. And this is saying, hey, there's no coyotes here in this picture that was taken on the first day at time 0, so at like midnight, 12 a.m. Right, so if I sort by day, you can see it better here. Right, so then later on, an hour later, there was a coyote, and it's still raining heavy. Right, an hour later after that, there was a coyote. An hour there was, and then there wasn't, etc. Right, so obviously, if you're triggering photos versus taking them on certain intervals, then you'd want to change the way that your data is set up. Right, I am just using this as my data. So the first thing that we need to do is we need to import this data into SPSS. So I've opened up SPSS here, and I'm going to then close this so that it can actually have access to it. I'm going to import my Excel sheet. It's just on my desktop, so I'm going to import it. Importing it is normally fairly accurate. It normally gets it right most of the time on most of the variables, not all of them. The different views that you can see here, right? This is the actual data, pretty much the same view that you saw in Excel just a second ago. And then it has variable view, so it can actually show you the data a little bit clearer. In terms of like the way that SPSS thinks that the data is set up, the most important one for us is the type of data, right? Whether or not it is a string, as in like A, B, C, D, E, yes, no, dog, cat, green, red, blue, right, are all string data versus numerical data, 0, 1, 0.5555, right, whatever, all numeric. If those are correct, and I think those are, right, I don't think it's interpreting those as wrong right now, we can look at the measure, whether or not it's measuring it as a scale data, ordinal data, or nominal data. Scale data is something like temperature, something like body weight, something like glucose concentrations, right? Something that can exist from a scale from X to X, right? And any number in between there can be that value. It is a theoretical possibility. Ordinal data is categorical data that has an order to it. Things like first, second, third, in terms of for our time of day is going to be an ordinal data for us because it's the first hour, the second hour, the third hour. It's categorical data, but in order. And nominal data is data that is a categorical data that does not fit into an order. I like the picture, right? Blue, red, green. Green is not better than blue, is not worse than red, right? So we wouldn't order them that way, but they're still separate categories. So for us, precipitation is a good example of that because it's light, none, or heavy, right? We could order those, right, if we think that there's a relationship where we would think that none is light is somewhere between not light and heavy, right? We could order those, but that'd be kind of how we'd want the data to be set up. We could just change that on the fly. So I'm going to fix all these so that they actually are right. Nominal, scale, ordinal, because the days are in order, times in order, and precipitation. We could probably put that in order, but that's okay. We can just keep it in nominal. And then now that my data is input, I have a fake column that is just gotta get rid of it. I'm going to go to Analyze, and then I'm going to go to General Linear Model, and then I'm only trying to understand the presence of an absence of one thing, so it's going to be a univariate. And then when I drag this back over here, the univariate general linear model is saying, okay, there's a couple factors. There's things like fixed factors. These are categorical data. So things like the day, the time of day, precipitation would all fit really nicely into those. There's random factors, which I'm not using in this, so we don't have to bother too much with them. That would be like if I was tracking particular cameras through time, right? That maybe like if I had multiple cameras set up in different areas that were all collecting data at the same time, right? The whether coyotes were present or absent would be tied to that particular camera, but I'm not doing anything like that for this. And then covariates are scale variables that are influencing it. So temperature would be a really nice one for this. And then I need to put coyotes, whether or not coyotes are present or absent is my dependent variable, the thing I'm predicting. However, SPSS does not like it when string values, so yes and no's. So what I need to do before I run this GLM is I need to change these yes and no's into binary data. So I need to transform them. I go to the top right here where I say transform, and I could either recode these into the same variables and just change this whole column. I prefer to recode into different variables so that it's going to make like a new column here that has coyotes present, but the data being transformed into binary, into string from string values to numeric. So I'm going to say binary coyote present. So now it's going to give me a new column here with that name. And then I need to tell it what to interpret those values are, right? This can be a major pain, but since this is only binary anyway, it's not that hard. So I can say if I see a value of no in the old column, I want to recode that as 0. If I see a value of yes, not test, if I see a value of yes, I want to recode that as 1. So I'm recoding those values so that SPSS knows what it's doing. Okay, I hit OK. And now I recode it, and now it shows up as the way that it can actually interpret that data. It just needs to know what's up and down. So I go back to my univariate model. I put my binary coyotes in there. I put what day. So I could make an argument for, so time of day and precipitation would go in here. Oops. And then temperature would go in as a covariate. You could make an argument for not including day if you like don't think that the first day of camera trapping is going to be any different than the 5th day of camera trapping. I probably wouldn't want to include that in here unless I had a reason to think that there was some difference. That would be like days of the week, right? Monday through Friday might have different traffic patterns, and then maybe that affects something, but not for this. We don't care about that. So I'm just going to leave that out, right? I don't think it's part of the model, so I wouldn't want to include it in the model. I can select this model, and I would want to just look at those main effects. So I'm going to build the model as, okay, what is driving this? I think temperature, precipitation, and temperature are. If I wanted to, I could include interactions between things, where if I think like rainy, warm days are going to be coyotes interpret rainy warm days differently than they interpret rainy, cold days, right? So there's an argument to be made for that, but unless you think that there's some justification for it, I generally keep those out when I'm looking for simple models. Then I have built my model, right? It's going to do that all on its own, so you don't really need to build it, but I wanted to show under the hood. And then you can do more stuff if you want to make things more complicated for yourself, or you can just hit OK. When you hit OK, it spits out a output file and then says, hey, you have a 6 days of each time of day, because we have 6 days total. You have about one heavy day for every light day for every nut, and 2 for none, right? So most of the time it wasn't raining. And then the important stuff here is, okay, we are trying to understand, it doesn't make it any bigger, never mind. We're trying to understand what is driving something in this model. So we look at, okay, is precipitation? No. Significance of 0.114 tells us it's not significant. Time of day, even less so. Temperature, even less so from that. This is not terribly surprising because I just made this data up, right? So this data is completely randomly created. If I want to test and see whether I'm doing something right, one thing that I could do is I could go back to the data. So now I'm looking at presence or absence of the coyotes, and if I want to see if this is actually working like I thought it would, right? So when I'm looking at this, I see that precipitation has a significance of 0.114, right? So now what I'm going to do is I'm going to play with the data and I'm going to make up data again, right? So I've sorted by precipitation. So if I think that, like, if I want to see whether this is actually having an effect, oops, I don't have 100. What I'm doing is I'm just changing the data. Obviously, don't do this. This is obviously not a good idea to do. Even if you think that you're not going to do it, occasionally things get saved and then you have to go back in and find out where you've made your error, right? So I'm changing this data only to show the effect here. So now with new data, if I were to rerun the same thing, I can go down here and select univariate, or it has this handy little box that just recalls recently used things. So I can just click on that, and so you can see all the stuff that I've already done commonly, and then it pulls right back up the exact same thing. I don't really even need to change anything. It's already going to copy and paste what I had done previously. And if I were to do it again, well, now you see here, precipitation was significance of 0.1, right? Not significant. I wouldn't think that the precipitation has a relationship to the coyote presence. But now that I've gone in and specifically said a bunch of coyotes showed up when it wasn't raining, now precipitation is a significant driver, right? So there is a effect of precipitation in the model. So that's how you would go about and saying, hey, I think that precipitation is driving the presence or absence of coyotes in the system. What time of it is has no effect. Temperature appears to have no effect. So that's how you would go about doing a real simple, general, linear model in SPSS. Mileage may vary. As you do more complicated things or you tweak and modify stuff, you're going to have to change the way that your data works, change the way that you interpret things. Thanks.